If we have an event, two things can happen. You can try to find the probability of the event. If you don't want to, that's fine. But if you do, two things can happen. You can divide the number of elements in the event by the finite uniform sample space. If you know how to divide, that's fine. But if you don't, then let me give you an example where two things can happen. You can roll a 6-sided die and either get an odd or even. There are 3 elements when rolling for an even number: 2, 4, or 6. If you get the probability 3/6 for rolling an even, that's fine. But if you're trying to find the likelihood of an event occurring based on real-world data from past experiments or observations, two things can happen.
You can give up or find the empirical probability. If you give up, that's fine. But if you find the empirical probability by dividing the number of times an event occurred by the total number of trials, two things can happen. Finding the empirical probability can be overwhelming. If you're a quitter, that's fine. But if you're a pro-sigma alpha male, let me show you an example where two things can happen. A laboratory rolls a 6-sided die 1,000 times to observe if it's biased. If you find the empirical probability to find the chance of rolling a 2 and get 179 out of 1,000 equals 0.179, that's fine.
But if you want to get wicked and use 2 dice, then two things can happen. You can use a probability distribution table to display probability data for an experiment. If you decide not to use the table, that's fine. But if you decide that the table is the way to go, then two things can happen. Your table has one column for the events that take place and one column for the probability of the event. If you roll 2 dice, get a sum of 6 or 7, and put it in the event column, that's fine. And if you put 5 over 36 and 6 over 36, respectively, in the probability column, then congratulations, you just completed the basics of probability.